All right, we are live. Welcome. This is just finish our teacher workday. So hopefully that y'all are enjoying your break. We're gonna get at it right now, right off the get go. Welcome to the teacher locker room, essentially. So this is our teacher lounge. If you haven't seen it, the math building teacher lounge. So everyone's gone home, but we like to stay a little bit later so we can have a nice little help session. So what we're gonna do is I'm gonna start sharing my screen and get going. So if I'm sharing my screen, I gotta figure out which one I'm sharing. I think I'm gonna be sharing this one. Start screen sharing. All right. And so for today, we're just gonna look at a couple problems and just make sure. Now I'm using my Wacom board. And so if you are with me now, just kind of chat below. Let me know what's going on. You can tell me what you're doing today, what fun things you did. I'm using Coach Jay's little thing right now, just because I have couple things acting up. But let's just get to it. So we're gonna start looking here at sum and difference angles. We'll start there and just kind of work through the study guide. And so with the sum and difference angles, we're first looking at the cosine of 45 plus 30 degrees. Now, when we're looking here for sum and difference, the main goal is to identify which of these out of the sum and difference or out of the double angle formulas we'll be using. Now, if I'm looking at cosine of 45 degrees plus 30 degrees, that's essentially going to be looking at the cosine of 45 is the cosine of A plus the cosine of B. So we're identifying A plus B cosine. So essentially looking at this angle here. And so with that, not angle, that equation. So what that equation tells us that we're going to do the cosine of A, which is 45, times the cosine of B, which is 30. And then we're going to subtract that from the sine of 45 times the sine of 30. Now, we are also identifying cosine and sine of 45. Remember that the cosine is the x value, and the sine is the y. So we're looking at the cosine of 45 degrees, which will be root 2 over 2, times the cosine of 30 degrees, which would be root 3 over 2. And then we're going to subtract that by the sine of 45, which is, again, will be root 2 over 2, times the sine of 30, which is 1/2. Remember that sine is your y, cosine is your x. When we're multiplying radicals, you're multiplying the values that are underneath the radical. So that'll be root 2 times root 3 will give us root 6. Another helpful reminder for us is that we are also multiplying the denominators when you're multiplying radicals. So that's going to be, or fractions. When you multiply fractions, you're going to keep the denominators by multiplying them. And then for the numerators here, you're going to get root 2 times 1 to get the square root of 2 over 4. Now from there, I got root 6 over 4 minus root 2 over 4. And what we want y'all to do is just simplify as much as you can. So we can simplify that by one step because those denominators are the same to leave us root 6 minus root 2 over 4. And again, if you have questions throughout the podcast, just let me know. Hey, Thomas Kenworthy, glad you're here. Shout out to you. Thank you for being here with us. And so let's keep going. Now, next one, we're going to look at tangent. Now, here's the thing. This is in radians. It's in 5 pi over 12. It is in radians. But one thing that we can do is convert this into degrees. Now, how do we convert it into your degrees? You're going to multiply that by 180 over pi. And again, if y'all have questions as we're going, so I know Thomas is here. So Thomas, if you have any questions, we just ask away and we'll get to it. When we're multiplying 5 pi over 12 times 180 over 12, that eventually simplifies to 75 degrees. Now, how do I know that? Well, you're just going to do 5 times 180 divided by 12 to get that 75 degrees. Now, the tangent of 75 degrees, again, when first identifying, is this a sum or in difference formula, or is it a double angle? Now, if it's not, like double angles we're going to be mainly looking at these far right equations. So we can identify this as a sum and difference angle because looking at 75 degrees, if I doubled, I can't really use the unit circle to double something to 75, but what I can do is have it where it adds to 75. So that, again, 45 and 30 both add to 75 degrees. But for me, I'm not going to use 30. I want to do some subtraction. And so I'm going to try the subtraction method. So I'm going to actually use 135 and 60. So we're going to do the tangent of 135 minus 60. Now remember, tangents are going to be bigger problems. It's going to have a little bit more work. And so when we're looking at the tangent, we're doing tangent subtraction. So we're going to be using this one down here. Tangent of A minus B, where A is 135 and B is 60. Now, again, I converted it into degrees just because a lot of us, our mind works in degree mode. So we're going to do tangent of 135 minus the tangent of 60, and then divide that by 1 plus tangent of 135. Now this is multiplied by the tangent of 60. Now tangents are not on our unit circle, but one thing that we can do is in our class we kind of talked about, okay, let's find the tangent of pi over 6. Well, how many 3's are in 6? 2. So that tells it that tangent is root 3 over 3 for pi over 6, or 30 degrees. And then it's going to be 1 at pi over 4 and root 3 at pi over 3. Now we can use the idea of coterminal angles or reference angles to help us the tangent. So at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, they all share the same tangent. It's just whether or not it's positive or negative. So if I'm looking in quadrants, tangents are positive in quadrants 1 and 3. And they are negative in quadrants 2 and 4. So when we're looking at the tangent of 135, I notice that 3 pi over 4 is the angle. So a reference angle is pi over 4. And because that is a reference angle, I know that this tangent will be 1. But here's the thing. Tangent is found by doing sine over cosine. So we have a positive over negative, which means this should not be 1. It should be negative 1. Now it's just a plug and chug. So we're going to, wherever we see a tangent 135, we're plugging in negative 1. Wherever we see tangent is 60, we're plugging in that root 3. So that'll give us negative 1 minus root 3, and then 1 plus negative 1 times root 3, which eventually simplifies to negative 1 minus root 3 over 1 minus root 3. Now, this isn't done. We had to simplify this. So we simplify this by multiplying by the conjugate. What the conjugate is, it's essentially the denominator with the flipped sign of whatever is next to the radical. So essentially, if the radical is negative, you're going to make it positive, and vice versa. After we multiply by the denominator, we now need to FOIL. FOIL is first, outer, inner, last, meaning the first times the first to get negative 1, and then the first times the outer to get negative root 3, and then using the insides, multiplying those two together, and the outsides. Now when you multiply a negative root 3 times a root 3, that becomes negative root 9, which eventually simplifies down to 3. Now that we did the numerator, let's do the denominator. 1 times 1 will give us 1 times that root 3, and then we'll get negative root 3 times 1, and then the root 3 times root 3 to get negative 3 again. Now we're not quite out of the house yet. We got to simplify. I'm looking at the numerator here. I notice I have a negative 1 and a negative 3. I can add those to negative 4. And then I have a negative root 3 minus root 3. Notice that we won't add these to get negative root 6. There's an understood 1 instead in front of both these values. So when we're adding radicals, that's going to give us a negative 2 root 3. And then finally, looking at the denominator, you have a root 3 and a negative root 3, which essentially cancel. And then we're left with 1 minus root 3 to get negative 2. Are we done yet? No, we're not, because we had to simplify this. So we're going to get -4 over -2, or -4 minus 2 root 3 divided by 2. Notice what's in common with all these values. If I look at 4 and 2, and I notice that -2 goes into all these. So I'm essentially dividing -4 by -2 to get me a +2. And I'm doing -2 root 3 divided by -2 to get me a positive root 3. From there, we are done. Now, tangent's going to be the hardest one to work with, but again, we'll have, if you practice, you'll get perfect. So now, again, same thing. We had 5 pi over 12. Now we're sitting at sine of 7 pi over 12. And so if I'm looking at the sine of 7 pi over 12, I'm going to do this one a little bit different. Rather than multiplying it, changing it into degree, I'm going to think about it in radians. So if I'm thinking about it in radians of 7 pi over 12, I'm going to think what values to add up to 7. Well, 1 and 6, 2 and 5, 4 and 3. And so I'm choosing values that essentially can go into 12. So what values add a 7 that go into 12 when multiplied? Well, I know 4 times 3 gives me 12. And then 4 plus 3 also gives me 7 pi. So since I'm adding these two, what I'm going to do is look at those two angles and then simplify them. So 4 pi over 12 plus 3 pi over 12 will simplify to pi over 3 and pi over 4. Notice that there's a trend. We've been doing a lot with 75 degrees. It's not always going to be 75 degrees like on the test. Like you might see something like 165 or 15 or 105. It's just 75 is just what I'm using right now, just in different measurements. So again, once I've identified my angle A and angle B, I need to look at my trig function, which in this case is sine. And after I look at my trig function, or that trig ratio, I'm taking the sine of an angle plus an angle. Well, that looks like this one right here, sine of an angle plus an angle. So we're going to do the sine of pi over 3. We're going to multiply that by the cosine of pi over 4. Then we're going to add that to the cosine of pi over 3 times the sine of pi over 4. Now, when we're evaluating sine of pi over 3, I'm going to pi over 3, and I'm looking at the sine, which is the y value, so that's going to be root 3 over 2. And I'm multiplying that by the cosine of pi over 4, which is going to be root 2 over 2. And then I'm going to add that to the cosine of pi over 3, which is 1/2, times the sine of pi over 4, which is root 2 over 2. And when we simplify this, root 3 times root 2 will give us the root 6. 2 times 2 gives us 4. And then we're going to have 1 times root 2 to get root 2. Divide that by 2 times 2, which is 4. And so finally, we will get root 6 plus root 2 over 4 as our final answer. Very similar to the one that we worked out a couple seconds ago. Oops, what happened here? There we go. And so let's keep going. We've worked out about 3 problems. We'll see how time goes if we'll work out every problem on the guide, but I'm just going to work out enough so that we kind of understand how to work these problems. So again, when you're working these sum and difference problems, you're going to look and see, do they match any parts on the left or any parts on the right? And that's going to be for the sum and difference or the double angle. Now, they're going to be mixed together, so you have to decide this on your own. So if I'm looking at number 4 and I have a sine times a cosine plus a cosine times a sine, I'm going to be looking then, where's the sine times a cosine plus a cosine times a sine? Well, that's going to be clearly right here. I like these ones better because all you're identifying is, okay, if this is the sum and difference, I'm doing sine of A plus B. So sine, I have to now identify my A angle, which will be 80. So I'm going to sine of 80. Oh, you know what? This is the one that we messed up that I told you all to change on your review guide. So this should be 70 instead of 80. So on your review guide, you should have changed that. So then that'll be 70. And then our B angle will be 50. So we're really just evaluating the sine of A plus B. This expanded version essentially just gives us where specifically this angle is found. So then I'm looking at then just doing the sine of 120, which means I'm going to the angle measure of 120 and looking at the sine, which is root 3 over 2. See, I think y'all are going to like these expanded problems a little bit more. I love them. They're quick, they're easy, they're not involving too much math. Here's now taking a look at question 5. Now, again, we're always identifying where on which one of our formulas are we using. So I'm taking the cosine squared of an angle minus the sine squared of an angle. So it looks like my angle is equal to 75. I don't have a second angle. One good thing to know, double angles only have one angle, while sum and difference angles have two angles. So if you're looking at expanded versions, if there's only one angle, that means you're going to be using a double angle formula. If there are two angles, you're probably going to be using a sum and difference formula. So that's a good, nice little hint for you there. So where is cosine squared of an angle minus sine squared of an angle? Well, right here. So when we've identified the angle, we're really just looking at this part here, this cosine of 2 theta, because we've got the expanded version. What we're looking at doing is condensing it, meaning I'm going to take the cosine of 2 times 75. And that's going to give me the cosine of 2 times 75 will give me 150. So what's the cosine of 150? Again, just going to 150, looking where cosine is the x value, which is that negative root 3 over 2. So again, these expanded problems, they're not hard. They're rather simple for us. It's just more of like, okay, can I identify which angle I'm using, and can I evaluate the trig function or the trig ratio? So again, looking at my equation, 1 minus 2 sine squared, where's 1 minus 2 sine squared? My angle looks like pi over 12. And so looks like I'm using this angle right here, but specifically using this cosine of 2 theta. And so to evaluate this function, we're going to do 2 times the angle measure was pi over 12. Well, how do we evaluate this? Well, first off, we're going to have it where it's 2 pi over 12. Now, the question we have to ask ourselves, can it simplify? And in fact, it does. Simplifies to pi over 6. So we're then looking at where the angle is at pi over 6. And after we find that angle, what's the cosine? It's just root 3 over 2. So I know I'm moving rather fast. I'm just moving quick because these are the quick ones. These are the ones that when you're on the test, you should be able to move through them pretty quickly. And so now let's take a look at this 2 tangent. Now, tangent, everyone's like, oh my gosh, we got to worry about tangent. Worry about tangent. You don't have to worry about it if it's on the expanded version. So looking at 2 tangent, looking at my tangents, is there one angle or 2 angles? Well, I see that there's only one, which means that angle is pi over 8. So that means I'm being drawn to this double angle formula. After that, I'm going to look at the tangent of 2 theta. So this is tangent of 2 theta. We have 2 tangent A divided by 1 minus tangent squared of A. Well, here's a great thing about this. All I have to do again is worry about doing the tangent of 2 theta. So we've already identified our angle as pi over 8. So we're going to do the tangent of 2 times the angle that we identified. We identified the angle as pi over 8. So this is going to really just be the tangent of 2 pi over 8. Well, that's just going to simplify to pi over 4. Now, tangents, these are things that we have to remember. One thing I recommend doing when you get your test, just write down the tangents. Root 3 over 3, 1, and root 3. And again, these are the easy ones. This is the tangent is 0, while tangent is 1 over 0 here, which we know to be undecided. So the tangent of pi over 4, again, is just going to be the value of 1. So we got 7 down. I want to look at, let's keep going. Let's just work through them all. It's just good to get this repetition in for sum and difference. So again, the whole idea is identify, is there one angle or is there 2 angles? Well, I only see that there's one angle here, and that angle is 22.5 degrees. Now, if it's one angle, we're using the double angle. Where's the 2 sine of theta cosine of theta? Right here. But I'm not worried about this stuff on the right. What I'm worried about is just calculating the double angle. So that's just going to evaluate this, we'll do the sine of 2 theta, so 2 times 22.5. Well, if I do 2 times 22.5, that'll give me 45 degrees for the sine. And how do we find the sine again? You just find out the angle, and the sine is the y. So then that's just going to be root 2 over 2. Two more. Here we go. Let's do 10, and then we'll do 9 next. Now we have the cosine of 2 times 22.5. If that's correct, we need to solve this. Here's the thing. Now we only get one angle, the angle being 22.5. But notice what's going on here. I could solve it, and in your mind you think, oh, I had to do this 2 times this, or I had to do the cosine squared of 22.5 minus the sine squared of 22.5. Well, that's a little much. Here's the thing. First, multiply this and see what you get. If you do, you'll find that 2 times 22.5 is 45. So this is a trickster problem, because the trickster problem tells me that I don't have to break it up into here. I'm just going to solve and evaluate here. So a cosine of 20 or 45 degrees is just root 2. So let's see. Can you go to the bathroom? Yes, you can go to the bathroom. Enjoy the bathroom. Hopefully that you're enjoying it at your home. So Caleb Aguilar, thank you for letting me know. So let's see, what are we looking at next? Oh yeah, going to number 9. Now you want to hold it right now if you want to use the bathroom. You're welcome to. But look, we got looking at sine 105. This is different. We had to identify. This is just one that we had to see. Is this a double angle? Is this a sum or a difference formula? So looking here, we got the sum and difference, because double angles are essentially we're not going to give you one. And really, if this was a double angle, like sine of a double, like 90 was the double of 45, 90 was the double of 30, 60, all of our angles are here. So whenever you're having just given one angle like so, more than likely it's going to be a sum and difference formula. So then I need to find out what 2 angles adds or subtracts to 105. So I mean 105, I know 135 minus 30 works. I know that 60 plus 45 works. I know that there are 150 and 45 work. I mean, it doesn't matter. It's just choose the one that fits you best, or the one that pops in your head first. So usually when I see 105, 60 and 45 popping in my head first, but I don't think we've done a sign subtracting one yet. So let's do that one. Let's do 150 minus 45. Or 135 minus 30. That might have been someone's easier one. So that means I'm going to say that angle A is 135 and angle B is 30. So that means I'm going to take the sine of 135 times the cosine of 30. Subtract that from the cosine of 135 and the sine of 30. Well, the sine of 135, looking at 135, the sine should be root 2 over 2. And then we're going to multiply that by the cosine of 30, which will give me root 3 over 2. And we're going to subtract that from the cosine of 135, which is this negative root 2 over 2. I'm just going to throw this negative in parentheses just because that helps. And I mean, I could throw all these in parentheses. It just depends on how your mind works. And then the sine of 30 to get that 1/2. When I multiply all these, this will give me root 6 over 4. Since I have a negative times a negative, that's going to give me a positive root 2 over 4. When we combine these, we'll get root 6 plus root 2 over 4 because of that common denominator. So we've worked out a lot of problems, but here's just we're going to move on to the next section. So if you have any questions regarding sum and difference formulas, here's the thing. Through all of these, here's the main concept that you need to know. Sum and difference formulas require us to use 2 angles. Double angle formulas require us to use 1 angle. So if you're working on essentially right to left, or essentially reducing, if you're reducing these equations, identify the angles, and then you're eventually going to evaluate something that'll give you a value on the unit circle. If you're working the other way, going from essentially expanding the formula. If you're expanding the formula, it's not going to give you one of these angles here. It's going to give you something a little bit more complicated, like what we did in the beginning, where it could be the tangent or the sine, something where it's a root 6 plus root 2 over 4, or anything like that. It just depends what angles you're looking at. And so that's for sum and difference. Now, we've looked at all of those. Now I want to move into double angles. So calculating the double angles for sine of 15 over 17, and I think if I'm correct, we changed this to be the secant of 25 over 24. So that was just a little quick change that we did in my class, just so that we could see something like this. So we had to identify first. Let's look for the sine of 2 theta. I'm going to evaluate the sine of 2 theta. First, I want to do is draw a quadrant, or draw my triangle. So if I'm drawing my triangle, I'm going to go right here, where my angle is located here. Now my sine is opposite over hypotenuse. Now how do I find this missing side? That's going to just use the Pythagorean theorem. 15 squared plus x squared is equal to 17 squared. Well, when I do 15 squared plus x squared is equal to 17 squared, that's going to give me 225 plus x squared to get 289. And then if I continue to simplify, I'd eventually get x squared to be 64, where x would be equal to the positive or negative 8. Because remember, when I square root, we get the positive or the negative. But in this case, it's all about what quadrant. In my quadrant, I know my x value is negative. So your y value should be positive, your x value should be negative, because in quadrant 2, we have negative x's and positive y's. So how do I find the sine of 2 theta? We're just going to use this equation right here, 2 sine of an angle, cosine of an angle. But how do we find this angle? Well, essentially what we're doing is not using the unit circle. So I'm not using this unit circle at all, so I'm going to just get rid of that. So what that I do when I find this angle, my sine of theta is 15 over 17. Well, we've already established that. The cosine of an angle is going to be the adjacent over hypotenuse, so then that'll be negative 8 over 17. And then the tangent of an angle is going to be the opposite over the adjacent, which would just be 15 over negative 8. And so with these values, can we establish and find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta? And so for sine of 2 theta, I'm using this first equation. So that's going to be 2 times the sine of theta. Now, 2 times the sine of theta, cosine of theta. Now we know that the sine of theta is equal to 15 over 17. What's the cosine of theta equal to? Negative 8 over 17. And then we're going to multiply all these, which you can do in your calculator. So 2 times 15 over 17 times negative 8 over 17 would give me negative 240 over 289. So that's for the sine of 2 theta. Let's look at the cosine, the 2 theta, if we're going to look for the cosine. If I'm going to find the cosine of 2 theta, what I'm going to do, I can use any of these. Oops, it's my arrow. So I can use any of these three for the cosine of 2 theta. I just like to use the first one just because I'm just used to it, but you're welcome to use any of them. So I'm going to use the first one, cosine squared of a minus sine squared of a. So I'm going to have the cosine squared, which is the negative 8 over 17, minus this sine squared, which is 15 over 17. And that should give me my answer. So when I square these guys, I'm going to get 64 over 289 minus 225 over 289. When we simplify that, that would give us negative 161 over 289. Now, I do want to show you a nice little trick in your calculator, if I can do that. I might do it for the next problem because my calculator needs to boot up. So let's find this tangent then. Oh, here it comes. We'll solve this and we'll use the calculator on the next one. So if I'm looking for the tangent of 2 theta, tangent, one way that we can do this is plug in that value. So I'm gonna do one way and I'll do the shortcut on the next one. So for tangent, I can do 15 over negative 8 as that tangent value. And so I'm just using this one here. So that would be 2 times the tangent of 15 over a tangent, which is negative 15 over 8. And then dividing that by 1 minus 15 over 8 squared. Well, this will just simplify then to negative 30 over 8 divided by negative 161 over 64. When you subtract 1 minus 15 over 8 squared. And again, when you divide by fractions, you gotta multiply by the reciprocal. So it'll be negative 30 times negative 64 over 161. But when that simplifies, that will give you 1920 over 1288, which you could simplify that by using your calculator to get 240 over 161. Now, let me show you the shortcut on this calculator. So, with the calculator here, we found those values beforehand. So we found the 240 over 61, all that. I want us to plug, this equation right here into our calculator. And so to do that, okay. I'm just going to take my numerator and do 2 times negative 15 over 8. And that's my numerator. Make sure that the numerator is all in one parentheses and divide that by my denominator, which would be 1 minus negative 15 over 8 squared. Again, making sure everything is in the correct order. When I hit enter, I get this nasty fraction. But if you hit math, enter, that will simplify us to 240 over 161, which is the exact answer that we found. And these double angles do take a little bit longer, but again, it's just a matter of working through finding each one. Now, let me show you the quick method. And to show you the quick method, we're going to take a look at this one, but we're not looking at the cosine. I want to look at the secant. The reason I'm looking at the secant is just because you will be given one on the test that won't be one of the 3 trig functions that we're used to working with. And so we're going to have it where the secant is equal to 25. Okay, let's do erase, make this a little bit cleaner. So we're going to have it where it's the secant. The secant of the angle is equal to 25 over 24. There we go. Okay, so to solve this, here's my suggestion. If you got it in secant mode, convert it into cosine. So what's the reciprocal of cosine or of secant? The reciprocal is cosine. So the cosine is 24 over 25. Now I know it seems redundant. It's like, why'd you change it there and change it back? That's just because I want you to know, hey, you're going to be given one that can be a cotangent, a secant, or a cosecant. So you got to be prepared and knowing your statements. Now beforehand, or your reciprocal identities. I'm telling you, for this, you don't need your unit circle. What you do need is a triangle. And so what we're going to do, we're going to draw our nice little triangle here. Now, what quadrant are we in? In quadrant 4. What are the properties of quadrant 4? Well, that means my y is negative, my x is positive. One neat thing, hypotenuse is always positive, no matter what. So we're just going to let that be positive there. And so let's find some values. Now, cosine we knew to be 24 over 25. So that means we got to find this missing side. To find that missing side, we're going to do 25 squared is equal to 24 squared plus x squared. And just for the sake of time, I'm just going to give you the x rather than work it all out. So the x should eventually simplify to -7. And so that's just squaring both and then subtracting the 24 squared over. So this tells me then that my cosine of theta is 24 over 25. We already know this. Our sine of theta will be the opposite, because this is our angle, the opposite over hypotenuse. So that'll be -7 over 25. And then our tangent will be opposite over adjacent, which is -7 over 24. Now, what I'm going to do here is work out sine, cosine, but I'm going to use my calculator too. So with here, I'm going to do the sine of 2 theta. Again, I'm just going to use this first equation here. So if you don't know what you're doing, at least write down 2 sine of theta cosine of theta. If you do know what you're doing, keep going, and you should have the 2 times the -7 over 25, which is our sine, and then multiply that by the cosine, which is 24 over 25. Here's a neat thing. You have a calculator, so use it, and we're going to use it for this problem. So we have it where when you're looking at this calculator here, you do the 2 times. Whenever you have fractions, make sure that they are in parentheses. So that's 2 times -7 over 25 times 24 over 25. And when you do that, boom, there's your answer. Now, it's in decimal. We want it in fractions. And how to turn it into fractions is answer, enter, enter. Here's the thing. If it doesn't turn in fraction, it means that there's probably a radical involved. So you will need to multiply that out by hand. So our answer should be then -336 over 625. Let's look at cosine now. So we're going to look at the cosine of 2 theta. What I'm going to do this time, I'm just going to use this cosine, 2 cosine squared a minus 1. The reason I'm doing that is because what am I given? I was given essentially this cosine of 24 over 25. I didn't even need to draw a triangle to find that value. So in that case, I'm just going to write 2 times the cosine squared of an angle minus 1. Well, for cosine of an angle, I already know what that is. I know it's 24 over 25. Now, how can I solve this, you might ask? Well, we'll just do 2 times 24 over 25. Well, that's just going to give me 48 over 25 minus 1. Oh, well, I didn't square it. Oops, my bad. Sorry. Backtrack. There we go. I need to square this. So I didn't square that. Now, when we square it, we're going to get 2 times the square of 24, which is 576, divided by the square of 25, which is 625. Then we're going to subtract by 1. Now, I could continue on. I'm just going to use my calculator. And so when I'm using my calculator, I'm going to do the 2 times the 576 over 625. Remember that fractions are always going to be in parentheses. And it'll give us, again, we have a decimal, but we don't like decimals. We like fractions. Now give us the answer of 525 over 625. Now here's the thing. I could have done that first step of 2 times 24 over 25 squared minus 1. I could have done that. That would have been fine. Gives us the same answer. It's just a matter of how far you want to go. The more steps you show on your paper, the more likely you are to get partial credit. So we found out that this would be 525 over 625. Now, I'm saving the best for last. Tangent. I'm going to show you the shortcut that we use for tangent. For tangent, we know tangent to be sine over cosine. You can also treat it whereas tangent of the double angle of 2 theta will also be the same as sine of 2 theta over cosine 2 theta. The way that you know if you're going the right direction, if the denominator of your double angle for sine and the denominator of your double angle for cosine are the same, it means you're going the right direction. And so we're just going to do the negative 336 over 625. We're going to divide that whole thing by the 527 over 625. And now what do we do when we divide by fractions? You multiply by the reciprocal. And when we multiply by the reciprocal, what happens to those 625s? They essentially cancel out, which will leave us with negative 336 over 527. This way is a lot better, and that should be a 5. It's a little sloppy, but it's a little bit easier to work out. To check and see if it simplifies, you could get your final answer and just go negative 336 divided by 527. Plug that into your calculator and then do the math into enter to see if it simplifies. If it doesn't, well, you got your answer right there. And that's essentially double angles. Now, is the screen is on me. Oh no, how long has this been on me? Let's see. Thomas, are you still watching? Let me know. I don't know how long the screen has been on me. Okay, so it worked out the sine of 15 over 17. Okay, so for that little, so what we didn't get then was the secant problem that we just solved, is what you're saying. Well, that can be fixed. See live. Okay, back here at this problem. So basically, I'm just going to explain what I did with this screen. You heard me talk through it. I'm sorry for that little miscommunication, that little mishap. So let's fix it. Now, all you see is a lot of work. Now, here is our shortcut here. Thank you, Thomas, for letting me know. We had the sine double angle. First, we had the secant here. The secant of an angle was 25 over 24. Well, we have to think, what's the reciprocal identity of secant? Cosine. So that's going to give me cosine of an angle to give me 24 over 25. And so this is going to be cosine of 24 over 25. Well, now we got to create a triangle. When we create a triangle, we have it where it's the 24 as your x, 25 as your hypotenuse, because cosine is opposite over hypotenuse, or x over hypotenuse. And then how did we find sine? Well, we did Pythagorean theorem. 25 squared is equal to 24 squared plus x squared. That eventually found it where x was equal to negative 7. And so we got that negative 7 there. And eventually we did cosine is, we know, the, just a little recap, opposite over hypotenuse. Then we had, not opposite over hypotenuse, adjacent over hypotenuse. Silly me. Cosine is adjacent over hypotenuse. The sine is opposite over hypotenuse. And then the tangent is opposite over adjacent. So this is our adjacent side, our opposite side, and our hypotenuse. Hypotenuse, there we go. Well, after we've identified all three of these, we then look at doing our double angle formulas. Now, double angle sine 2 theta, if you don't know it, just write down the equation. But by this point, we should know that the sine of theta, we're just taking the sine of theta and plugging in the value of -7 over 25 because it's equivalent to. I could find the angle on this, but because it's equivalent, where sine of theta is equal to -7 over 25, that's equivalent to it. So we're just going to do 2 times -7 over 25. For the cosine, cosine, again, it was this 24 over 25. And so we're just going to plug this in here, and then it's a plug and chug. Now, I'm going to show you what I did with my calculator here. The calculator, let me see if I can scroll up. I'm just plugging it in right here. So I just plugged in 2 times negative over 25 times the 24 over 25. Well, this thing here, again, gives me a fraction, but I don't want fractions. I want decimals. How do I get that answer fraction? Math gives you here. You'll just hit enter, enter, and that'll give you your answer every time in fraction form. For cosine, we had cosine double angle. I chose this second one this time rather than the first one. I chose the second one because I just want to show you I don't need to sometimes use this triangle. I can just use the value given and then use that formula. So then 2 cosine squared, I'll just plug in the 24 over 25 in the square and double it and subtract 1, and that'll give me 525 over 625. Again, on your calculator, you can just plug it in and chug it, plug it and chug it. That'll be good every time. And again, you can turn that buddy into a fraction. If you turn that buddy into a fraction, you'll be set and good to go. Now for tangent, the shortcut that I want to talk about is tangent is sine over cosine. Same thing works for double angles. The tangent of 2 theta is going to be equal to cosine of, or tangent of 2 theta is going to be equal to sine 2 theta divided by cosine 2 theta. So that'll give us this -336 over 625 divided by 527 divided by 625. And then what do we do when you divide a fraction on fractions? So if you got fraction on fractions, multiply by the reciprocal. So then that's just going to give you -336 divided by 625 times 625 over 527. These two guys cancel out. And once they cancel out, we're left with here. To see if that reduces, use your calculator, double check, and you'll find out in this case it does not reduce. Just a helpful reminder, if you try and simplify it and you can't simplify it to a fraction, more than likely there's a radical involved. And so you'll have to do it like what we did on the quiz. And we will look at one of those problems tomorrow in class. So now we've looked at sum and difference. We've looked at double. Now let's go into solving equations. And so we got about, I think, 4 or 5 problems that we'll do for solving equations because I got about maybe 15 more minutes left till I have to go somewhere. So let's take a look at 16. When we're solving equations, the whole goal is to isolate the trig function. We want to isolate this trig value right here, this sine of 2x. We want to isolate that, meaning get this by itself, meaning if I had sine of 2x minus 1 equals 0 or plus 1 is equal to 0, I got to get rid of that plus 1. Keep in mind, if the 2x is not in parentheses, it still means it's an angle. Sometimes they will be shown with this like here. So how do I get rid of that with -1? I just subtract. So then this will give me the sine of 2x is equal to -1. So let's keep going. How do we solve this, though? The way that we can solve this is since we have sine 2x is equal to -1, once I've isolated the trig function, I'm going to bring out my angle and solve for my angle. So first off, my angle is 2x. But what am I setting 2x equal to? This 2x is essentially a theta. I want to find where the sine of theta is equal to -1. Meaning, what angle is y -1? So I'm going on my unit circle. This is essentially the idea of inverse trig functions. So where is sine -1? Where is y -1? It's located right here. Are there any other angles that gives me where the sine is -1? No, this is the one and only place. So then that means I'm going to have 2x is equal to 3 pi over 2. So we're not looking at the -1, we're actually using the angle. And the thing is, if you have a tutor, they're going to tell you something about adding this 2 pi k thing. We are restricting it by just looking at the values that are first found. We're not going to be looking at the infinite values. We're just going to look for solve for one angle. So one solution per angle is what we're looking for. So you're not going to be wrong on the test if you're using that plus 2 pi k method. But just letting you be known for if you do have tutoring in the next couple of days, we're just solving for one solution, not multiple solutions, just the one solution per angle. And so how do we solve for this x? Well, we just divide by 2. But here's the thing. I talked about this in class. We could divide by 2, but the issue with that, it gives us problems, fractions and all that hurts us. So one thing that might be a little bit easier is multiply by the reciprocal. So if we multiply by the reciprocal, this 2 is really 2 over 1. So these 2's cancel out, which will leave us an x. So then we're just going to have 3 pi times the 1. So you multiply the numerators together, and you multiply the denominators together. So then that would give us x is equal to 3 pi over 4. And boom, we're done right there. Quick, easy, not too terrible. Let's take a look at the next one. Again, the goal is to isolate the trig ratio, or the trig function, essentially. Isolate the trig function. So that means I want to get this cosine of x by itself. Now, how can I do that? Well, to get things by itself, the best thing to do is subtract or add whatever's there. So I'm going to subtract by root 3 on both sides to give me 2 cosine of x is equal to negative root 3. Now, how do I get rid of the 2? Divide both sides by 2. So now I left with cosine of x is equal to negative root 3 over 2. And again, we're using the unit circle now. I'm not using these formulas, just using the unit circle. So where's cosine of x? Where on the unit circle is it negative root 3? Meaning where on the unit circle is the x value negative root 3 over 2? And that will be located here and here. Now notice, we don't want the degrees, we want the radians. So this is going to tell me that x will equal not only just 5 pi over 6, but it also will equal 7 pi over 6, because you're locating all opportunities, all angles there. And then after you've identified all angles, from there, you can just set it equal and solve for x. Now, in this case, you can write it like where there's 2 separate x's, or if you want to do x is equal to 5 pi over 6 or 7 pi over 6. Either one's fine. Either method's fine. So that's just our solution for 17. Again, if I'm going too fast, please let me know. So we'll keep going. So here's, this is very similar to number 1. Because we've already isolated, we've gotten the sine by itself. So I just need to find out where sine is negative root 2 over 2. So looking where is that negative root 2 over 2. Remember, sine is the y. So cosine is x. Sine is y. And so sine negative root 2 over 2. Where is that? Well, sine negative would be in 3 and 4. And negative root 2 over 2, it could be located here at 5 pi over 4, and here at 7 pi over 4. So what I'm going to do after I've isolated the trig function, I'm going to locate the angle where sine of an angle is negative root 2 over 2, And then I'm going to set that 5 pi over 4. That's going to be equal to whatever my angle is here, this 4x. And I'm setting it equal to 5 pi over 4 and 7 pi over 4. Now I got to get the x's by itself, and that's the easy part. We're going to multiply by the reciprocal on both sides, and we multiply by the reciprocal, we'll get 4, or x is equal to 5 pi over 16. And then we multiply by the reciprocal on the other side to get x is equal to 7 pi over 16. So then our final answer will be x is equal to 5 pi over 16 and 7 pi over 16. And again, it's isolate and solve. Now we're going to get into a little bit more complicated problems. And so this one involves some factoring. Now, here's the thing. We can approach this multiple ways. But if we're ever going to factor, we have to make sure that the equation is equal to 0. Is it equal to 0 right now? Nah, it's not. So I got to set that equal to 0. So the way we set it equal to 0 is first I'll just subtract 3 on both sides to get cosine of x squared minus 2 cosine of x minus 3 is equal to 0. Now we need to factor this guy. So if I'm going to factor this guy, I'm going to do this idea of substitution and just substitute a cosine with an a, just because it's a little bit easier to solve. And so remember, when we're factoring, you're looking for something that multiplies to -3 that adds to -2. In that case, I know it's going to be -3 and a positive 1. Once I've factored it, make sure to bring this cosine back in, because we're going to bring, once this cosine's back in, that's going to help us remind us that we're going to need to solve for 0. Now, here's the thing. Once you get it into this kind of parentheses form, you want to set both sets of parentheses equal to 0. Now, here's the reason why. If cosine of x minus 3 was equal to 0, does it matter what cosine of x plus 1 is? No, because what's anything times 0? 0. So that means I'm going to set this cosine of x minus 3. We're setting that guy equal to 0. And then we're going to have cosine of x plus 1 equal to 0. Now let's look on the left side. If I get and isolate my trig function, that's going to give me cosine of x is equal to 3. Is there anywhere on the unit circle where cosine is 3? No. Can't have any value greater than 1. So that means on this side, it's no solution. That's not the whole part. That's just one section. Now let's look then here. If we subtract the 1 on both sides, we'll get cosine of x is equal to -1. Where's cosine -1? Right here. So that means cosine of x is going to be equal to, well, not cosine. That means x is going to be equal to pi. That's our final answer. That's not telling me that cosine of x equals pi. That's not true. That's not true at all. It just tells me that my angle measure is going to be pi. So that's, again, for factoring. When we factor, we have to look at those options. So I'm running a little short time. Let me see which ones I want to solve left. Okay, so we'll look at solving 3 more. Yeah, we'll solve 3 more here. And then I'll ask if there's any other questions before I go. So we're going to look at right here, 21, and 21, 22, and 23. Those will be our last 3 for the podcast. So for 21, cosine of squared theta minus 1 is equal to 0. Again, we're going to try and solve this through factoring again. So if I have cosine of an angle minus 1, I want to, again, isolate this cosine. So if we're going to isolate the cosine, we're going to add 1 on both sides. You could substitute this out for an a. That's fine. You can do that. I'm fine with that. But I just prefer not to, just because it's going to be a little bit easier this way. Now, how do we get rid of something of cosine squared? The way that we can get rid of it is by square rooting. When you square root that guy, you're going to get the cosine of an angle. Now, remember, when you square root, you will always get a positive and negative answer. So now we have to identify where the cosine is positive and negative 1. Well, I know its cosine is positive 1 here, so that means that our angle is going to be for sure 0, while the other angle will be pi. Now, here's one thing that I want to remind you. Our interval is 0 to 2 pi. 2 pi is not included as an answer. So the angle would not be 2 pi. It would be the angle equal to 0. And so that's how we solve those types of problems. Now, if I'm looking at something like 22, we know the process. We know that it's if you have something here times another value. So if you have cotangent of 4x times tangent of 2x plus 1 equals 0. It doesn't matter what either one of these are. We're going to set them both equal to 0. So we're going to set cotangent of 4x equal to 0. And we're going to set tangent of 2x plus 1 equals 0. Let's solve for this tangent one first. So to solve for the tangent, I'm going to subtract 1 on both sides, and that's going to give me tangent of 2x is equal to negative 1. Now, I know in your mind you're going to be like, oh, boom, I need to divide the two. No, not yet. The trig function is isolated. So what we have to do now is identify where is tangent negative 1. Well, I know tangent of 1 is involved with anything that has a denominator of 4 in terms of radians. It's positive in quadrants 1 and 3, and negative in quadrants 2 and 4. So that means that my angle measure is going to be 2x will be equal to 3 pi over 4, and 2x will equal to 7 pi over 4. To solve, we're essentially just going to multiply by the reciprocal, which would then give us 3 pi over 8. And, oops, working too fast. And 7 pi over 8. Now, again, that happened just by multiplying by the reciprocal, which canceled out these 2's. And same here, multiplying by the reciprocal. Now, let's look at cotangent of 4x is equal to 0. Now, I don't quite know where cotangent is, but I do know where tangent is. Now, when we're looking at the reciprocal, I'm not flipping my angle. I'm flipping this sign. So this 0 is like a 0 over 1, kind of. And so because of that, let me give it a little bit more room. So again, we're not flipping the angle. This is like 0 over 1, or it could be 0 over negative 1, because I know that it's just using these values. Cotangent is cosine over sine. So I'm really just looking for my angles where cosine is 0. So that means I'm looking here at 0 and here. And so that's going to give me where 4x will equal to pi over 2. And 4x will equal 3 pi over 2. To solve this, I'm just going to multiply by the reciprocal. On both of these guys, just multiplying by the reciprocal. So then x would be equal to pi over 8. And x would be equal to 3 pi over 8. So as our final answer, we'd have pi over 8, 3 pi over 8, and 7 pi over 8 as our answer. So for the last one for the day, and then we'll be done, is let's take a look-see at this one. Okay, so for 23, to solve this, I need to, you could do the substitution, but again, that's going to make things more problematic than they need to be. And so what we're going to do is figure out, can I factor anything out? So what I mean by factor something out, looking at the cosine x minus 2 sine of x cosine of x, what is in common with both terms? I know immediately you think, oh, there's an x in each one. That's true, but an x is just representing an angle. So what we're actually going to do is factor out the cosines. So I'm going to pull out this cosine here, and then it'll give me a cosine x times 1 minus 2 sine of x. Now, you might be asking, why is a 1 here? Well, this is essentially 1 times cosine of x. So when I pull out the cosine or factor it out, I'm leaving behind a 1. Just like when I factor out this cosine here, I'm leaving behind a 2 sine x. Now, this is cosine of x times 1 minus 2 sine x. So now we're just going to do what we've been doing all day. Set 2 parts equal to 0. So we're going to say cosine of x equals 0 and 1 minus 2 sine of x equal to 0. And just solve. So where's cosine of x 0? Well, interestingly enough, it's in 2 locations, pi over 2 and 3 pi over 2. So we get pi over 2 and 3 pi over 2 as our answer. And now what about for here? How do I get this? Can I get rid of that 1? So subtract 1 on both sides to get negative 2 sine of x is equal to negative 1. Then I can divide that out by negative 2 to get sine of x is equal to 1/2. So sine of x is equal to 1/2. Where is sine 1/2? Looking at our unit circle, looking for the y values where it's positive 1/2, which is here and here. So that tells me x will be equal to pi over 6 and 5 pi over 6. Now you could box both of these answers and be fine, or you can label them all out. I'm fine either way. So then I'll just be x is equal to pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. Now that concludes the podcast. I'll give 1 minute for anyone that's podcasting here for any questions, or I'll give a couple minutes, not just one, just a couple minutes. If you have questions, please type them now. And I appreciate y'all for watching, whoever watched. So I see that 2 people are watching now. So out of those 2 people, ask away. No mas, no more questions. All right, well, hey, that concludes it. Tomorrow, just keep in mind, this review guide needs to be completed for homework. We're going to have a Jeopardy game, and I'm excited for tomorrow. So 3rd period, just letting y'all know, y'all are combining Mr. Sorry and Mr. Lawless's class. We're combining. We're going to have a little class competition. Whoever wins will have some prize for y'all. So come prepared and come ready. Now let's see how I can close this out, and we'll be done. Go Dogs.